This video, we host a number of issues all centered around towing and safety considerations, so you're not going to want to miss this one. Hi friends, I'm glad you found this video. It's a real important one. I'm talking about the considerations for towing, whether it's safety or proper connections. It's a real important thing, and I want to share with you some of the experiences that I've personally gone through, my friends have gone through, and a vast amount of research to try to impart that knowledge and experience onto you to save you some headaches and some of the work for you downstream. Today we're going to talk about the electrical connections, the physical connections. We're going to talk about some special considerations for different vehicles, and then we're going to talk about some safety concerns. The first thing you got to make sure is that you've got a good electrical output to your Towed, because you're going to have to supply your Towed with 12-volt constant power, and I can't emphasize that enough. There have been a lot of problems. At the minimum, a dead battery. At the most, a fried transmission. There's all sorts of problems that have been circulating around as a result of not tending that battery, making sure that battery is constantly being charged. Unfortunately, the new vehicles have a lot of electronic systems that are constantly activated, even when your Towed is in a tow mode, a neutral mode. And by having a 12-volt constant power fed to a battery tender, which is something simple, you can get on Amazon. I'll put some links below for those parts. I think Brake Buddy makes one. You can get one from E-Trailer. Kurt makes one, and you can spend anything from 30 bucks on up. It's a real simple wire though. It's a standard 12-volt hot wire, positive only, and it goes from your 6-pin here up to your battery, and in that there will be a block in there that's got a diode to make sure that the battery supply power does not go backwards into your coach. You want the coach's battery supply to go towards your Towed. So they do that with a diode, which is a simple gate, like a water gate. And it also will have a fuse in there. And that's connected right to your positive terminal on your battery. There's nothing more you need to do, because then when you connect your coach with the cable, it automatically feeds that. Now, I'm going to show you a little bit of a hybrid system that I've been working with ever since I transitioned from towing an F-150 Ford, which had a transmission problem because it came out of neutral tow. That's a whole different traumatic experience that I don't want to talk about today, but that led me to rethink a lot of things. Right now, I'm towing this Jeep Grand Cherokee Trailhawk. It was highly recommended by several people, including my friend Tim, who said he towed successfully for years, and it was just a real simple, straightforward system. And I have to agree, it's a one-button neutral tow. You don't have to worry about turning the vehicle back on or off or putting in or out of gear to test all that, which I like. I like being able to positively test things. So one of the procedures in a Jeep is you can, once you're in neutral tow, you can put it into drive and reverse and make sure your vehicle's not moving back and forth. And that's a good positive way to make sure two things: that you're definitely in neutral and that your parking brake isn't set. This 21 has a manual brake, which was another big criteria for me. I did not want an electric parking brake, because if you give that energy or you give it a signal and that parking brake kicks on, you're in for a bad problem down the road, literally. So that's one consideration, talking about neutral tow. And in this case, I am not supplying the Jeep with any power, and I'm going to go through the reason why I'm doing that for now. One of the things that the 7-pin supplies, besides power, is it supplies brake and turn signals. Now, that requires a physical line connection from the coach to the 6-pin, and it's a translated cable too, by the way, because this is 7 pins and that's 6 pins. So I can't be clear enough to make sure that this is energized. There are a lot of coaches, Newell included, that do not have a 12-volt 24/7 power to it. It's for a number of reasons which we don't have to go into, but you just have to do your homework. Make sure that that pin down there is in fact 12-volt hot. And it's generally a standard that the center pin on your 6-pin on the Towed side is where your 12-volt hot lead comes to. But since my good buddy Al gave me this, I wanted to try it, and it's pretty slick. I can put the Amazon link for you in the description, but I'm going to show you how this works. It's actually a wireless battery and turn signal, and it goes right into the 7-way, and that actually energizes the little transmitter in there. And all you got to do, it's got an internal battery. You can leave it plugged in if you wish, but you can charge it, and it's magnet mounted. So you just clean those babies off, clean your roof off so you don't scratch it, and stick it right on there. Turn that baby on. It'll go through a little diagnostic test for you. Once you get in the coach's cab, you can test left, right, brake, and it works slick. So guess what? There's 0 battery draw on the Toad. There's also no possibility of that Jeep's electrical system waking up for some reason, because here's another consideration. And we found this by a lot of research and a lot of mistakes, trial and error, and experiences from other Jeep owners. The newer Jeeps, again, the models vary slightly, but the newer Jeeps have the option to have LED taillights. Now, I haven't tested this empirically, but there's plenty of research out there. There's actually a company that's making a special harness for the Jeeps with an LED taillight option. So what's happening is there's a diagnostic signal that comes from the LED taillight circuits to talk to the computer. And apparently that's constantly being activated, or is continuously activated. And that's causing that computer to draw the batteries down. So if you have a Jeep that has LED taillights and you're having battery issues, that's your source. Again, you still have to have that battery tender hooked up, but they make different wiring harnesses specifically for a Jeep. They've got plug and play harnesses, which I am a strong advocate of. Plug and play, so you're not cutting any wires. You're basically pulling a connector apart and you're putting like a CURT wiring harness into that circuit. Me personally, I didn't want to interrupt that. And my friend Al, he had a Grand Wagoneer that is, again, kind of like, it's almost like a CAN bus electronic network in these cars now, and it worked fail-safe for him, and I like that idea too. It's a good auxiliary to have and not tap into the vehicle, and you can move it to vehicle, and you can also not worry about drawing power because of something that's activating your electronic system in your actual Toad. There are other issues that, for example, on a Jeep, there's the electronic power steering. There have been some issues with people talking about the death wobble and power steering not being activated once you disconnect. I can tell you I've tested on this 21 Grand Cherokee, and I can tell you absolutely that if you follow the recommendations in the manual, you won't have a problem. Here's why. There's basically a sleep when the electric assisted power steering comes into play, and when you come out to disconnect your vehicle, and the people who are leaving their vehicle running while they disconnect, those are the people who are having problems, because it quite clearly says in the manual to disconnect your Toad with the engine off. So you set your parking brake, you take it out of neutral, you come in here and you disconnect your system. And what happens is during that time period when your vehicle is turned off, the time it takes you to disconnect your tow system is enough to reset the computer, and when you go back in to turn it back on, you've got full electric power steering. You're good to go. It's worked for me every single time. So those are some special concerns. In this case, I've talked about the Jeep. I hinted a little bit about the F-150. I'm not going to get into the discussion, but just yesterday, I responded to yet another problem with a Ford that came out of neutral tow and fried the transmission. It's a big problem, and I don't want to spook people, but I successfully towed my F-150 for 5 years, about 40,000 plus miles, not a single problem. I replaced a battery, I replaced a transmission, and all heck broke loose. And there is a belief that AGM batteries are pretty finicky when it comes to voltage fluctuations, and that might be a clue to the puzzle as to why these are slipping out of neutral tow. Now, I touched on it briefly, but it's abbreviated EPB, the electronic parking brake. There are ways to get around the electric or electronic parking brake problems. For example, the GM products like if you have a Yukon, a Denali, an Escalade, an accepted procedure is you put a battery disconnect circuit, some type of a rotary switch, a key switch, or wire in a relay which has a solenoid up there which breaks that circuit, and it's operated by a push button that you can mount under the dash, hidden out of view, or some people will actually mount it outside somewhere hidden so they don't have to take a manual key and open the car door and then flip that. Now the problem with that is if you do put it inside the vehicle and you've killed your battery and you lock your doors, you're not going to be able to get into your vehicle. So some people say, I don't care about locking my doors, I just leave them unlocked. That's your choice. If you choose to lock your doors, you have to have a game plan. You got to have your key with a manual key, and you have to find where your emergency key port is. They hide them on some vehicles, like on the nice Denalis and the Escalades. They put it in a hidden cap underneath. Some cars, like my truck, had the key port right on the outside of the handle. Didn't have to pull a cap away, just put the manual key from your key fob in, open up your door, and away you go. Re-energize your battery, and you have to do some steps on some vehicles. They, for some reason, want you to cycle windows up and down. Some people claim they lose their memory presets, their AC controls. So again, if you got a vehicle, and unfortunately, we're getting closer and closer to almost all vehicles having some type of an electronic system that's going to stay activated. You got to do your research on individual vehicles to see if that's a good vehicle that you want to tow with. If you can follow the procedures and, take your time, and you should be fine. So now that I've talked about the electronic or the electric systems, let's talk about a little bit more the physical hard systems, the nuts and the bolts. This system is pretty much straightforward in terms of vehicle and RV in terms of alignment. And by alignment, if you look at this tow setup, that once the tow is connected and backed up all the way, and your arms are extended all the way. This isn't quite extended, but I wanted for the video purposes to see the relationship here. The relationship that I'm going to address right now is that you want this tow system to be as parallel with the ground as possible. Or I should say, you want the offset from the receiver of the RV to the tow pins to be as minimal. Different manufacturers have different parameters, but by and large, it's about 3 to 4 inches of offset, high or low. So you don't want your tow pin on your tow to be way up here or way down here, vice versa. If you've got a really high coach, someone like coaches like Renegades, they sit substantially higher. Some guys who lift their Jeeps have a substantially higher ground clearance, and that's going to drive these pins up a lot higher than recommended offset. So if that's you, you're going to have to match that to your own individual setup, that you have to have a riser. Very rarely do you have to have a dropper on these low slung, like the Newells almost always have to have a riser because they're so low anyway. And you have to have a riser. Some have to go 6, 8, some more than 8 inches. And that creates some extra stresses, because remember that when you have a riser, you've got lateral forces as you turn back and forth. You're no longer just pulling this hitch to the side, you're now twisting it, because you've got a riser up here that's now somewhat of a lever to cause twisting. So you just have to take that in consideration, because even though you're just gently pulling and gently braking, you're not really dragging something with resistance. You don't have a lot of tongue weight like a trailer. You're just basically pulling this dolly along, if you will. You're still going to have lateral forces and some forces that are linear to the coach. So you just have to kind of take that in consideration and plan ahead. And I always like to think, what happens if I have a failure? Have I addressed backups? When you connect your receivers, we have an adapter here, and so it goes from 3 inch down to 2 inch. So we have to have a reducer in here. That creates extra length, and it also creates an extra connection. Because of these extra connections, it creates a lot of rattling and a lot of slop in here. Each connection up here has a potential to vibrate back and forth, rattle back and forth, and cause slop. So I choose, as many of you have already done, to use hitch clamps or hitch stabilizers. Some of them are called quieting clamps, but my favorite company is actually, they're made in Texas. It's a USA company. It's called HitchClamp USA. And this is a big monster here. This is a 3-inch, and that's needed to go up and around. And it basically, it's probably hard for you to see, but this flange right here has a lip on it. And this U-bolt goes right up over the top of that flange, and then this bar comes down the bottom, and it doesn't take a lot of pressure. They recommend only like 25 foot-pounds of torque for these nuts down here, and it has a lock nut, and that's just enough to keep that thing absolutely solid. I did the same thing. This is a different type of hitch stabilizer. I don't like it as much as the hitch clamp because you can see here it has a plate on the bottom, and this plate doesn't lock as positively around this flange. It tends to dance a little bit or walk a little bit. It still keeps it perfectly stable and perfectly quiet. In fact, it handles the brunt of the securing of this pin, because you'll see this pin is still loose. So this is being held in place literally by this hitch clamp right here. This one up here is tight, but I highly recommend getting these. Again, I can put links in the description below. So that gets the connections up here solid, and the next thing you've got to worry about is your safety cabling, and we can address the issues on the base plates with so many toads problems that the base plates have come loose. And it doesn't have to be completely off the vehicle to cause a problem. And here's why. As you're driving and that base plate is wiggling back and forth and has a little bit of play, it can create micro fissures and cracks in that base plate and or the frame. I had that happen on one of my vehicles, and the only way you can prevent that from happening is to get under there and mechanically, physically check those nuts and bolts to make sure they're constantly tight. And for example, Roadmaster, and I believe Blue Ox does as well, they suggest using red Loctite. So that's the strongest. It's Loctite 271, it's the red, and it's basically what they would call permanent Loctite. So you get in there and you dope that bolt up or that nut, and you make sure that that thing is not going to back off just from vibration and the heat stress, cold stress. But that doesn't relieve you of your responsibility to check it. In fact, this is a fairly new Roadmaster pin, but I just took the sticker off. There's a warning sticker here that says, caution, check this every, I think they said 3,000 miles. But most of us, most of our friends, they make sure that when they connect this like I do, I wiggle this, I look physically, and I'll put my hands down there, and I'll actually feel the plate against the bolts to make sure I don't have any play whatsoever. Now, if you can do this, I would highly suggest that you get a safety tether, especially if you've got an auxiliary bumper that's not a factory bumper. I have seen where aftermarket bumpers have come off the vehicle. Well, guess what happens? If your pin system is connected to your bumper and the safety cabling is attached to the bumper itself, your whole package, the bumper, the tow bar, everything is going down the street, and your vehicle is going the other way. Not what you want to have happen, which is why you should have a breakaway cable, okay? We'll talk about that in a minute. But if you have a safety strap down here, the safety strap will fix the base plate to the frame of your toad, so that if something catastrophic happens where that base plate cracks, breaks off, the bolts break off, something where that base plate lets go, that safety tether will keep that intact and hold it. It's going to cause damage, but it will at least keep that toad connected to your coach. I've seen that recently where it was on a Cherokee, and that just rattled after time, and that base plate fractured and bent down and just came right off and just caused all sorts of damage. They were lucky it didn't break off completely. So this system here is under a lot of vibrational stress, and you just have to keep after it. And I'm an advocate of replacing the system routinely. That's going to be up to you. I know that people that argue vehemently, oh, I've been pulling this thing for 120,000 miles for 10 years. You know, God bless them if they have any problems, but me personally, I like to replace this periodically. So I start fresh, and then I don't have to deal with any mechanical fatigue factors. Now, I indicated that you should have a breakaway cable. The different brake systems, the auxiliary brake systems, have a supplemental breakaway switch. In this case, I'm going to show you a Blue Ox Patriot. But regardless of what actual supplemental brake system you have, they almost all have some type of a breakaway cable. In this case, it just goes to a simple contact switch here in this port, and once that pin gets pulled out, it just causes the contacts to close, which sends a signal into the braking system to say, hey, you need to activate because we have a breakaway. So auxiliary braking systems, probably by far the most popular braking system is the Air Force One by Demco, and it's a brain that sits up in the firewall area of your engine compartment, and it uses vacuum and an air supply from the coach. It's a fantastic brake system. It is basically completely hands-free in terms of hookup, because once you connect that air line to your coach, it activates the Air Force One, and it has a tattletale light that goes behind your mirror so you can see it in your camera that your brake is constantly working. It's just a really great system. It's expensive to put in. It can be a couple grand and more to hook up with a good installer. Some people do it themselves, but I wanted to try something a little different this time. I wanted basically what's called a plug and play system. I wanted to be able to have this vehicle as untouched as possible for a couple reasons. Number one is we weren't certain if this was going to be the vehicle we wanted to keep long term, and I didn't want to put a lot of extra money and work into a vehicle I wasn't going to keep. What I elected to try is this Blue Ox Patriot brake, and I picked it up. It was a really good unit. I picked it up used. They're pretty pricey. I think they're up to like $1,700 now. I picked this one up for a fraction of that. I think it was under $500, and gave it a test, and it really is slick. All you got to do is plug it into a 12-volt power supply that they have a cigarette lighter adapter. And I have to caution you, don't just assume that the one under here is going to be 12-volt power 24/7, because this happens to be the plug for charging phones and whatnot. And it turns off once the ignition is turned off and the vehicle goes to sleep. So you have to test it on your own to make sure that whatever you plug into is in fact 12-volt power, even when you turn the vehicle off, you close and lock the doors. And in this case, in the console, we have just that. It even has a battery symbol on here, 12-volt DC with a battery symbol. And just plug that baby in there, and it sits right on the floorboard. I'm going to swing around and hopefully not get in the camera's way, and I'm going to show you how easy and how fast this is to connect. So with the Patriot in place, it has a quick and easy clamp that goes right over the brake pedal, and you just push it forward and it locks in around, and then it has a safety lock here, and that's all it does. It's just a jaw that goes right around the brake pedal. So now that the Patriot is connected to the brake pedal, the next thing you got to do is you got to run the seat up till it just barely presses these pads, and I accomplished that with memory preset on the door, and I just run it to memory preset 2, and it runs the seat forward. Next thing you do is you power it up, and then you hit setup. Now it's going to calibrate itself. It's going to push back against the seat, push against the brake pedal. It's going to come back, and once it's done cycling, it's going to cycle back, and when you get a green solid power light, that's all you need. You're good to go. Here's my breakaway pin cable, and it goes right in there, and believe it or not, that's all there is to it. It takes literally 40 seconds to connect this. And when you're done, just everything in reverse. You can stow this back behind the carpet back there, turn your power off, put your seat back to memory 1, take your lock off, pinch the jaw clamp open, reach over here, pardon the reach, unplug it, and away it goes. It's out of the vehicle. They give you nice little dogs back here to wrap the cable. And I got a nice little Milwaukee bag. Fits right in there. Even has a couple of pockets in there. I can take my little receiver, or I should say my little transmitter for the brake light. Put that in there. Pretty slick. I don't even think it weighs 6 pounds. And I can either leave it in the back of the vehicle, put it in the coach, put it in the service bay, whatever I want to do. I just like that. It's kind of an auxiliary system that I can plug and play. I can take this to another vehicle if I choose. Best thing is, there's no physical connections to my Jeep. It's as if it never had a brake system installed. So I like it. And so far, it's working great. For those that might want a little bit more portability, this is a pretty good way to go. Well, that's a wrap. I know that was a lot of stuff to go through. Hopefully it answered some of the questions and concerns that you've had. There's a lot of things that are left to the professionals. There's a lot of nuances that I probably didn't cover, but this gives you an overview of some of the bigger concerns that have come up that are circulated around the community. I just thought it would be really good to bring a few of those to the forefront for you to consider or happen to look at stuff that you may be overlooking. And it's very easy to do. There's so much stuff going on here, but hopefully this video helped you out. If it did, do me a favor, give a thumbs up, like on this, and if you choose to, how about subscribing, and that way you can come back as often as I produce these things, or maybe even more often. Until then, I want to wish you safe travels and have a great day. Thanks.